We have in PROFINET services that are capable for network topology. Network topology means that you have, on the one hand, this physical topology where you go from device to device, but also this physical topology you can use in your engineering system. Why does it make sense? It makes sense so far that you can then have a much better diagnostics of your machine, because if several devices would fail, then the question is it because of the device is failing, or which is device that is failing, or is it a broken cable that could happen? And then this topology information makes the diagnostics of the station much easier, because then you see where does the failure starts. That means in case of these two stations would fail, then either that station here has a problem, that device has a problem, or it's the cabling in between. And that's why this topology information is something that is taken by many, many devices. But to ensure that the topology is working, we need MAC addresses not only for the interface, we also need MAC addresses for each and every port, individual ones. Why is it required, and why is it there? If we design a device with a two-port interface already, then it becomes interesting to go for conformance class B. And for conformance class B, it means that we have then also topology information. But to get this topology information, there's one additional thing to be mentioned. Topology means that we have the ability of the device to detect who is my neighbor. Somehow the device should know this, should learn this. So, and that's why we distinguish now between two types of protocols, two types of, in the end, also two types of addresses that are used here. One thing is for the interface. This is, let's say, the well-known MAC address of the device, which represents the device entity itself. So this is the network entity of the device, and it will always go with that MAC address into the world and talk with each and everybody over that MAC address. But for the neighborhood information, we need such link local frames. That means frames that are only for that local link here, which must not be forwarded to other stations. And to distinguish between the interface and the local port addresses, it is mandatory to have different MAC addresses for the ports and for the interface, and they must be unique. This is something that needs to be taken into account when you produce these devices. That means in the end, a two-port device gets 3 ports. It is mandatory to know, and it's also something that needs to be reserved for a multiple port device, because we distinguish such called link local telegrams, the neighborhood information between these two stations. That means that station tells, you are connected to my first port, and I am the device whatever. I am device Alex. So, and the other one would be now device Emilia, and then so on the second port, I would also say you are connected to my second port, and I'm still Alex. And that one station that now recognizes, okay, Emilia would then see, okay, on my first port, Alex is connected, and will return back, okay, hi Alex, I'm Emilia, and you are connected to my first port. This is then the neighborhood information that is stored in each and every device. That is how the system would work. Totally easy, and therefore this distinguishing between the interface MAC address and the port MAC addresses must be there, because this will be the only chance how the station can also identify where does the information comes in, and can also then diagnose that this is a link local frame, or this is an interface frame which is delivered to somebody else. This makes the the Ethernet stack, and this makes the communication path easier compared to if everything would run on the same MAC address. The only station that could live with just one MAC address is the last one here, or that one, if it has just one port, as we have shown here. If this would be multiple ports, then we would have these MAC addresses. And you need to be sure that these MAC addresses are unique. It must not be in, it's not the rule that it is always a consecutive numbering, as we have here, 44, 45, 46. It could be also a mixture, but they should be unique. So you should not reuse MAC addresses for the ports here. For instance, then if you would install two devices from the same vendor, and you would say just, okay, my MAC address here is the interface MAC address, and the next one gets the next interface MAC address, then we would have double MAC addresses on the wire, because then you would say, okay, the 45 is on the left one, the 46 is on the right one, and then you would have here the 45 again, and 46 there, and 47 to the other one, and this would mix up, and double MAC addresses is something that is not identifiable. That's why please ensure that you have here unique MAC addresses. This is something you need to ensure in the production of your system, of your devices. That is important here. This is mandatory for having the service of network information, network topology.